Hi, this is Michael with Web Performance, and I am really excited to show you all the work we've been doing for Load Tester 7. I've been personally using it for the last 4 months in real life situations and just can't believe how much time it is saving me. It's been really exciting. So let's get into it. Let me bring it up. So you'll notice it looks a lot like the old one in general, but we put a lot of effort into cleaning this up and making it look more modern. So I hope you notice that, but the basic workflow is the same. And the way we usually start is recording test cases. So let's go ahead. So you'll notice that we still got a little dialog that pops up. The red, of course, means stop recording. And the little button right to the right means start a new page. We've now included 3 demo apps that you can practice on to do your test case development. The simple one just works with minimal input from you. The Pixie version with OAuth requires a couple of iterations with AI to work, and then the Azure SAML portfolio is, you're looking at a good 15 minutes interacting with AI to get that one to work. Let's just go with the middle one then, so we can show off the AI. Let me log in. So as you can see, it's your basic portfolio, stock portfolio app. So let's do a trade. Submit an order to buy some stocks. Go see what our new portfolio looks like, and then see what we've been doing lately for stocks, and then sign out. So pretty basic app, but underneath it's kind of complicated. So you may have recognized this window. We have this thing called ASM, which is automatic state management, and that has been really enhanced with AI. It's hundreds of times faster. A lot of the things that we relied on regular expressions before are now hand code or hard coded into Java. So this is going to do a lot of work for us in terms of configuring dynamic fields. And of course, you can still take a look at the content of the page. This works fine if you have a traditional app. Single page apps, not so much, but remember, this is a virtual user simulator, so often the definition of a page isn't straightforward, shall we say. All right, so this demo app, the programmer, in this case me and Claude, put page numbers instead of names on there, which is not good in a load test, because you want to look at the report and say, was the login page slow and not page 2? It doesn't make any sense. So let's ask the AI to help. So let's say examine each page and give them things that describe what they do. By the way, this is Anthropic's Sonnet model, but you can hook in any model you want. We're adding more all the time. All right, it's thinking, it's looking at each page. All right, so you've got login, OAuth, trade form, submit trade. So this is really accurate. This is pretty much what we did. The next step in this would be to try to do a replay. As you can see, the fields, we got a lot of fields correlated. It should work. Let's see what happens. We've got an error. But why? So typically this would take, when I recorded this originally, it took me 2 days to figure out. I had to go look into what Pixie spec and look at there's a code that goes back and forth that has to be generated, but let's see if AI can help. Okay, so I'm going to say fix the replay errors. So I created about 97 now different MCP functions. And the AI here has access to every possible bit of data. And so it doesn't get data all at once. It comes with a plan. It comes up with a plan and then collects the data that it needs to solve the error that's in front of it. So it looked at the very specifics of this error, looked to see what transaction it was on, and then worked backwards to see what could possibly be wrong. And so it's very specific. I programmed the agent to tell you what's going on in case you wanted to learn and be able to do it yourself. The other lesson learned here is that you don't want the AI to do anything without your permission, especially something that changes the test case. So in this case, it's going to ask for running a replay, and I'm going to say yes. We're going to give it another shot. We're going to try to replay again and see what happens. All right, another error, but the AI is on it. It was watching while the replay went. Notice that there was an error, and it's already investigating. The trade ID isn't being substituted correctly. All right, so it just configured a new extractor, which we in detection rule that we use to configure ASM. In the past, that would have been me looking for codes to see where they're set, and then creating a parser and testing the parser. This does all the things I would have done automatically, and then just sitting there waiting for me to approve it. So let's see if that worked. And wow. And it did it. Let's just see what it did. So tools. So here's the demo we've been working on. So this is the rule that it had to configure. It looks like it's looking for trade, capital A through Z, and a number. Confirm. So this is what it did behind the scenes. One thing I forgot to show you here is that you can configure multiple logins. You don't want to just log in by one user. So we have data sets. You configure different login names here. We've got all like up to 500. But the takeaway is this compressed what took me a couple of days to figure out into just a quick demo. So let's go ahead and start over, and let's see how running a load test works with AI. Let's just get it to start here and get it to ramp quickly, so we can just start at 200, maybe ramp for 200. Let's see if we can overload this quickly and find our bottleneck. And we're going to be looking at CloudWatch server to monitor what's going on. And of course, as always, you can generate load from the cloud using your own AWS account or your own Azure account. Or you can generate it locally if you have enough bandwidth and CPU from your local machine. Typically, when I'm working, I generate locally when I'm debugging my test cases and for doing low-level tests. But anything that requires a steady bandwidth and steady CPU, I always run that from the cloud. So let's let this ramp up, and I will come back in a couple of minutes and see what happened. All right, we've sort of fast forwarded. We've got 400 concurrent users. The average page load time is crazy, so something's really gone wrong, especially since if you look at the CPU on the server, it's only at 20%. No, sorry, 32%. Which still shouldn't be pegged. We still got plenty of memory too, so let's ask the AI. Let's see what it says. Root cause. Auth pages degraded 5x while the trade pages degrade only 1.3 times. So it's something in authorization. Likely culprit, the OAuth provider, thread pool, or connection limit exhausted. I put that bug in there, so I happen to know that's absolutely correct. The other thing that's really helpful here is ask for the slowest transaction. That usually sends you right to the specific thing call that you would need to track down. Oh, we're getting a bunch of 500 errors. That's not good. So what is the slowest transaction? That is, yep, that is OAuth, home login. That is exactly right, because I designed it to be single-threaded, so I knew it would be a problem. That's one thing I'm doing, is designing test websites with very specific problems and then training the AI on how to recognize those. Alrighty, so this AI assistant has access to everything in the app. So that means the servers, a high-level description of the errors from the browser side. But what it doesn't have access to is the backend. So that's where an MCP server would come in. You can connect Cloud Code or Codex, and then I happen to have given it access to the code for this, as well as the error log. So I'm going to say check the running load test. Examine the error logs to find the source of the 500 errors that we see right there, and then examine the code to find the root cause. So it also has access to everything in the app, all of the stats we're collecting. So it looks like it's going to do that first, see what's going on. So it narrowed down which is the important error. Often you get error cascades, so it makes it difficult to find which one was causing everything. So the prompts that are built in here it's following the same procedure I would follow when I would be debugging something like this. The difference is it's doing it much faster. And it found the bug that's in there where the authorization is single-threaded. So this is really helpful. So let's move on to the next thing, which is after you're done. Let's just stop the test. We need to go and look at what actually happened here. We've got two load levels. So this is completely written. The metrics dashboard is all new. That's sort of outside the scope of this. I do love the new analysis where you can look at the slowest transactions and get the same information the AI was getting. I think it's cool. It counts it by either average duration or cumulative time, which is very helpful to figure out where you want to put your performance optimization effort into. Usually cumulative time is a help because it's measures what the overall effect of a change is going to be. It may not be the slowest transaction if the slowest transaction is one that only gets called once in a while. But let's go on to the AI part. So this is the section where we generate a report. This whole thing is based on hundreds of reports that myself and my colleagues have written over the years. It uses the same general format. It relies on actual unit tested data. So the AI just isn't making up data. All of the data coming off here has all been unit tested from MCP functions. And the AI is looking for relationships in that data, but it never tries to like calculate things itself, which is always a problem point for AI. You never wanted to try to even calculate, even adding up numbers is problematic. That's why everything math related is all done in code and guaranteed to be correct. What we're looking for the AI is to try to look for relationships. Now, if it was a simple relationship like a correlation, that's being done in math, but it's looking for outside of the box things like patterns that we have told it about in the past. So you click on this button and it starts generating a report using the format and all the prompts and all the data that we've spent a good deal of time tuning to get good results at. And again, that's by not just looking at past reports that we've written and seeing what the relationship in the data is and telling it, but also by training it on creating demo apps and then crippling them and then putting those patterns in there as well. It's got a sort of a graph rag. So it's saying, all right, if we are seeing a flat scalability, the bandwidth is flat, and the CPU usage on the server is low, but the load time is going up, here's what you do next. Here's what it could be. Examine these things. So it's helping to guide it to come do the same things that we would have done if we were investigating this problem. So that's in the paid version. In the free version, you can use the MCP server, and the CLIs, the codexes in Cloud Code and Open Code, they do a pretty good job. But it's not the same level of professionalism. You're going to get some sort of ad hoc report as opposed to ours, which goes through a formula that covers everything that should be in a report. So that's the value add there. All right, so the amount of time it takes to generate this part really depends on how overloaded your favorite large language model provider is. But let me just give you a quick overview. Note that the language in here is actually based on our writing. It's not generic AI slop. We spent a lot of time creating a voice for a professional performance report that wasn't just whatever the AI happened to crank out. So here, let's go through, look at all the numbers. It's looking for problems, got all the charts already packaged in a nice report. Looking for server correlations. The place that I would caution you to look is that, so you're preparing to send this to someone, and you can export it to a docx, to a Word, and then start editing it. I would pay specific attention to these priority actions or recommendations, because these are often based on information it doesn't have. So it doesn't know what your performance goals are. It doesn't know how your backend's being configured necessarily. So that needs to be carefully gone through. But otherwise, it's when I've had to prepare reports, just getting all of the charts in the right spot and in a template here and getting all the tables is just such a huge time saver. So I think that's it in a nutshell. If you come across a situation where the AI couldn't configure your test case, or you felt like it gave you bad advice, let us know, because all those go into test-driven development. They go into an integration test suite and as an example of what not to do, and then we make it right. So I hope you get as much use out of this as I have. Drop us a line if you got any suggestions for fixes, but otherwise I really appreciate you taking a look. Bye for now.